Welcome to this third video, and in this one, we'll see how to take an input which is of various data types, and then uh, basically turn it to that type. Okay, so what do I mean by that? Whenever we take an input from the user, it is always in the form of a string. Okay, so it always has data type string. Okay, if you don't really believe me, let's uh, work with this first uh, this first input. Okay, let's use it over here. Since we want it from the user, we'll put it in double quotes. All right, and now we have to use the input function, right? So it will be inside the input function. So we have input, enter an integer. So whatever the user gives as input, we'll save it as I. All right, so int I equal to input, enter an integer. So that seems like a good message for user to see. After the user inputs data, this is our print statement, right? So let's put it in print function. So let us put it in print function. Okay, so I'm so sorry, I forgot to give double quotes and I cannot see where I am right now. Okay, so now here I have my double quotes, and then again over here, right? Okay, so this I complete this. Class int, as we had before, will be replaced with type function. Okay, type function of I. All right, for now we'll move with this. I'll not debug it. We'll see the errors and then we'll solve the errors. Okay, so let's have it this way. So I and the type of I. Okay, so now we saw dynamic typing, right? So it was when we had static allocation. What it was when we gave an integer, it gave us output as integer, and we when we had say uh, um float, it was a float, and correspondingly, right? Now, when we have an input, let's see what it gives, right? So now, when I run this particular program, okay, it's still the program 2 because we haven't typed it. We haven't completed. Okay, let's just run it. It says an integer. Enter an integer. I enter 23. Right. Data type of I is I. Okay, that was not supposed to happen. Okay, it was supposed to input data type of I is I. That is because I forgot to put double quotes. Okay, so it was considering the entire thing as string. Now we have the correct way allocate. So from this particular, see, this is the string 1, which is concatenated with this, assuming that it is an integer. It is not, but we'll assume that for now it is an integer. And then we have an integer, sorry, a string value from here to here, that is variable is, and then we have the type, okay, which again will be a string. All right, so after having completed it, we'll save this, Control S, and then go to our terminal. We run this program again. We give the same value, and it says the data type of 23 variable is string. All right, now this shouldn't happen. This happens because every time you take an input, okay, that input is in the string form. All right, because string is the biggest type of a string is a data type which can accommodate every other type of data type. Okay, so you can have numbers in there, you can have alphabets in there, you can have your special characters. Okay, so that is why the data type, the highest data type that you can get in a particular in Python is string. All right, or any other programming language for that matter. All right, so what do we have to do in order to convert this string into an integer? It's simple. We simply use the int function. So int function, if we add this int function, okay, in there as well as in here, okay, what will happen is our variable will be converted into integer, and then it will be saved. All right, so let's do this first and see how it works, and then we'll optimize it. Okay, so again 23. Now it is, see, it is an integer, so the data type of this 23 variable is int. All right, so I talked something about optimizing it. All right, so you see we are defining int I over here twice, right? So what we can have instead is we can keep I as it is. All right, sorry, I as it is. All right, okay, and over here itself, when we take the input itself, all right, what we can have is we can give this input to the integer function. Okay, so if we when we take the input, if that is in string form, right, this particular input is in the string form. If we convert that particular input in the integer form itself, then what we have is we have a typecast here itself. Okay, so we have, so you don't have, we should not have a dot over here. We are having a typecasting at the input itself. Okay, so what did we have? We have a typecasting at the input itself. All right, so now let's see if it works or not. All right, let's see, and then we'll debug if there are any errors. All right, so again we give 23. In case you are wondering, 23 is just simpler for me to enter. That is why I'm entering 23. All right, so the data type of this 23 is int. It works, right? So this is how we can have all the other values basically printed. Okay, so now what we can do is we can have the float value. All right, so how do we take a float value? Just simply copy these two. The other two are just copies, right? So I cut those, and I come over here and I paste them. Okay, of course I go to the end, I add some spaces just so that it is a readable file. Okay, this will be input. Okay, sorry, double quotes, double quotes. Okay, I go to the end, I put double quotes, right? Always see, what I will suggest is always try to follow the way in which I am programming. Okay, that is because it has a certain logic to it. All right. So see, what I did was I basically took what output I want. All right. I wrote the output, and now I'm making the changes in the code to make that output happen. All right. So I don't want this to be here. It will be given from the input, right? So whatever input I take, it has to be given to a certain function, and that function is float. Okay, so I put a bracket at the end. I put a bracket in the beginning. I write the function name, which is float. Okay, and then I have to assign this to a variable, whatever value which is taken from the input and typecasted into floating value. I have to save it into a variable. I will name that variable as f. Okay, so f equal to whatever is the input, convert that into a float and save it into this particular value f. Okay, so now when I come over here, this is my string value, right? So let's just first make it string, right? Entirely string. But wait, it's not entirely string, right? So let's convert this. It was type of f, right? It will be type of f this time, and there's a comma in between as a concatenation operator. The concatenation operator is not plus, it is comma this time. All right, and then again this is a string, right? So we have a double quotes over here, double quotes over here, a comma over here to concatenate. This string ends over here, and we have a comma, and then the variable name is f. Okay, so you can see the data type of this, the way in which this integer string was defined is the same way in which this one is defined, right? Instead of I, we have f. All right, so now we can give this string to a function. Okay, go to the end, add a bracket, come to the beginning. In case you're wondering how am I switching between the front and the end, for if you are using a desktop, a big size keyboard, then there will be home and end buttons, which you can use to switch. Otherwise you have control and the right side arrow, control and the left side arrow. To for Mac users will use command right and left. Okay, so we have print function which will do the rest. Okay, now since we have the same thing repeating once again, what I'll do is I'll just simply copy this particular print statement. Okay, command C. I just want it to be replaced, right? So command V. This is complex now, so F will become C. F will become C. Enter a complex number. That's my statement. So I'll complete this. I know for a fact that I need 2 over here, or maybe let's just go according to our conventions. Okay, so I have double quotes, then completing the string, right? I have to convert this I have to take this as input. Okay, and then I have to convert this into a complex. Okay, now let's just do this and see if it works. All right, so this is what is supposed to be given, and then we have C equal to, right? So we save this file and we run this file. Okay, So see it. All right. So we have a extra double quote which is not required over here. It was a silly mistake. Okay. Since I copied it and pasted it, I also forgot to remove it from here. Okay. Now this is something that is should be edited out, but let it be. All right. We are all learning over here. Okay. So now you can see I have my uh, terminal full. All right. So to clear my terminal over here, I press Control L. Oh, sorry, it does not work right now, but okay. All right. So basically, it all right. Okay, that was not supposed to happen. Anyway, so let's take another terminal. All right. All right. CD to desktop and then ls. Yes, there is my program. So Python prog2.py. All right. Oh, sorry, Python 3. So you can have too many errors. All right. So an integer 23, it's okay. 23.4, enter, it's okay. And then 23 plus 4 and j. Let's see. It's a complex. It works. All right. So that is the how we get our input values. All right. So after you get this, there is another part to this program, right? That is giving its equivalent binary, octal, and hexadecimal representation. Okay, the numbers that we have taken are decimal numbers. All right. So what is decimal number? It has 10 representations. If you count the digits that we have, the unique digits that we have, there are 10 unique digits. Okay, so 0 1 2 3 4 5 6 all the way till 9. Okay, so we have 10 unique digits. That is why it is called a decimal system. Okay, binary has 2, that is 0 and 1. Octal has 8. Hexadecimal has 16. I have explained this in a previous video. If you want more explanation, you can just search for any digital logic design video, or maybe computer architecture video, and have more explanation about this binary, octal, and hexadecimal representations of numbers. Okay, it's quite simple to understand once you know how to count, basically, with because we are used to counting with till 10, right? So once you get the idea, it's very easier. All right, so let's begin with the second part.